Okay. Now let's go to the next practical. Now we have completed the practicals related to waves. Okay. Now we are going to start the practicals related to light. Determining refractive index of glass using a traveling microscope. Before doing this practical, let's revise the real depth, apparent depth concept. All right. So let's say you have a glass tube or something like this. Okay. And you have a certain actual object here. Okay. You have a certain actual object here. Right. Like for this. So if you take it will like rays will go from this, right? Now if you are viewing this from at a point like this, what happens is this rays will go from dense to rare, right? So go like this and it will go like this. Okay. So you are the observer here. Okay. But the thing is, you see an apparent image as well. See somewhere here. See. Okay. So this is the so-called real depth, and this is the so-called apparent depth. Okay. This is the so-called real depth, and this is the so-called apparent depth. So I'll like now in the exam, in MCQs and in these practicals, you should memorize the equation of real depth of apparent depth. Okay. So I'll tell a way to memorize this. You can write real depth over apparent depth. And you can just draw a diagram. It's better if you remember the way of drawing the diagram. It's not difficult, right? Okay, first of all, let's talk about dense to rare. Okay. I mean, object is in dense medium. Object is in dense medium. Observer is in rare medium. This is the first application. Okay. Stick to this method. You will see that it will be very easy for you to complete past questions as well related to real depth and apparent depth if you understand this concept. The first model is the object is in denser medium and the observer is in rarer medium. Okay. If it is the story, we write real depth or apparent depth and we start drawing this diagram. See, a real ray coming from this, it's been deviated. And if we analyze this, we can see the apparent depth is what? Apparent depth is much lower than the real depth. Okay. Apparent depth is much lower than the real depth. And we know the refractive index of the denser medium is, rarer medium is much lower than the denser medium. So we can say real depth of apparent depth. Okay. Real depth is greater, so ND here and NR here is the equation. If it is dense to rare. Okay. And let's look at the situation if it is like rare to dense. Let's say you have a rare medium here. Right? If so, the situation is, let's say you have an object like this, a light ray will come out. It's true. Okay, light ray will come like this. And where will it deflect? This is dense to rare. This is rare to dense. Now it will go this way, right? If you draw normal here, it will start moving this way. It will turn towards the normal, right? Therefore, if you extend this ray, like this is the apparent depth you get, apparent depth, and this is the real depth. Okay, because this was the real depth at which the object was placed. This is the apparent depth. Now, in this situation, the thing is, let's say you are observing it from here. Okay, like this is like a fish who is inside the water observing a but a fish who is inside the water observing a fly who is above the water. Okay, a fish who is inside the water observing a fly who is above the water. I'll draw that diagram as well. Let's say you have the fish here. Fish is the observer and there's a fly here. Okay, so you can draw a light ray coming from the fly. Okay, so this is rare medium observer, dense medium object. Object is in rare, dense medium observer. Okay, so you can draw a light ray like this. It will come like this and it will go to the fish eye like this. Okay, this is how it goes. But the thing is, fish will see the apparent image somewhere here, right? So this is called the apparent height. This is called the real height. It's simple as that. If you take the real depth and apparent depth, it is totally the other way around. Okay, but you can see that the apparent depth is greater than the real depth, and we know ND. Okay, is greater than NR. So can write real depth of apparent depth equals. Since here the real depth is lower, we put NR here, OND. Because actually this real depth of apparent depth ratio should be less than 1, right? Therefore, rare medium's refractive index should be at the top. In this situation, the real depth, real depth of apparent depth ratio should be greater than 1, since real depth is greater than apparent depth. So the ratio should be ND over NR. Okay. So this way you can just by quickly drawing a diagram, because if you practice the skill of drawing a diagram like this, it will improve your like ability to answer questions related to light as well, the light lesson. Okay. So likewise, we can get the real depth apparent depth relationships. So there's no problem in that. Okay. So let's look at how we can do it using this practical. Hmm. What we do is here, we take this diagram. It might be much clearer than my note. No, it's not mentioned exactly that. Okay, so what we do is, first of all, we take a traveling microscope, which is clamped vertically, and we take a small, here we use a powder, right? Small dot of powder kept on the table, and we focus the traveling microscope on this. And then using this displacements, we can calculate the x distance. Okay, that means actually the distance which the traveling microscope was initially kept, right? This will get it as x. It's marked on this meter. Okay, and then what we do is something like this. Let I draw it here. First of all, we keep the powder and we focus the traveling microscope. And using this stand, we can calculate this height. Let's say that is x. And then we keep a glass cube and keep the lyconium powder at the bottom of the glass cube. Okay. So what happens is, okay, this is a which situation? Object in dense medium. Okay, because this is almost in this going through this dense medium. Observer is in rare medium. Object is in dense medium. Observer is in rare medium. Okay, so we can say real depth or apparent depth, okay, is equal to ND over NR, or simply real depth is greater than the apparent depth. We know this. Therefore, this will shift upwards somewhere here. Okay, it will shift upwards. Now this is the horizontal level. Now, if we keep the microscope now, the microscope should move a little bit above, right? To focus this properly, microscope should move a little bit upwards. That's obvious, right? Microscope should move a little bit upwards to focus. All right. So uh, our rule will measure the distance from this bottom. That's why. Okay. Therefore, we can say, therefore, distance shift is equal to y minus x. And what is the distance shift actually equal to? Hmm? Let's see. Wait a minute. I'll explain using this thing. Like still we can't get anything. Okay. I'll explain using this thing later. Now, let's say you got the distance as well. Okay. Now what you do is you keep the lyconium powder on the top and focus on it. Then you should further shift the microscope upwards. Wait with me until the story ends, okay? So then you will understand this. Now, again, you can get a, like, again, you can get a certain distance like this, is it, right? And you can clearly see, okay? Let's take it like this. If you want to calculate this apparent height, okay, you should have a little bit of understanding in this part. If you want to calculate this apparent height, that means the distance, let's say this is 1, this is 2, this is 3, okay? You know apparent height is the distance shift from 2 to 3, right? Am I correct? It's the distance shift from 2 to 3. That is the apparent height. So that is equal to Z minus Y. The real apparent depth, okay? The real depth is equal to the distance shift This distance shift is the most important point. From 1 to 3. Real depth means the distance shift from 1 to 3. So that is equal to Z minus X. Therefore, we can apply this equation. Real depth over apparent depth is equal to what? Dense over area. So Z minus X divided by, which is a larger value, obviously, Z minus Y is equal to ND over NR. Therefore, we can say the dense medium is glass and the rare medium is what? Air. And air's refractive index is almost assumed to be 1. So we can say N glass is equal to Z minus X over Z minus Y. I hope you understood this, right? Z minus X over Z minus Y. Okay. So if you still couldn't understand any point, you can prefer the video again. And if you have any doubts related to the teachings, you can question in the comment section, anything, okay? Or you can email, right? Points. This is more accurate since depths will be high. Now it's like this, yeah. So if you have the opportunity to take a certain glass block and keep it this way or keep it this way, don't use this, use this one. Because you will get higher depths. Okay? If any reading is higher in magnitude, that means the percentage error is lower. Okay, so that's the benefit we have in this arrangement. Okay, the layer of powder should be very thin because if not, it can make errors. Yeah, that's true, right? If the layer of powder, if you put a layer like this, a heap of powder, then there will be a certain height for this powder as well. So it won't properly be focused and we won't get accurate readings, right? You should assume that the powder is a point. So you should use a little bit of powder, not a lot, right? Can use this application to get refractive index of liquids as well. Yeah, we can do this to find refractive index of liquids as well. Okay, I mean, in that one, I mean, as I remember, there was a possible question related to that. I actually can't remember that question. I mean, it's very simple. Like, if you can get a powder which won't spread, or if you can simply take a small metal ball point, something like that, instead of this glass cube, okay, let's say you keep a liquid beaker of water, and the same principles apply, right? Just what you did is, instead of the glass, you kept a beaker of a certain liquid. So you can calculate the refractive index of that liquid as well, right? So that's a separate point. So this is all about the determination of refractive index of glass using the traveling microscope and a block of glass. Please understand properly this shifts, right? Distance shift is equal to apparent depth. And also understand the apparent depth, real depth concept, which I told you earlier. Okay. Because it will be useful for you in your theory and MCQ questions as well.